Hello, space fans. I'm Saxmo, and you're watching the Saxmo Space Show, a place where we discuss anything and everything space related, from science fiction to science fact, and everything in between. So, last week's scavenger hunt question was: what was the first man made object to reach outer space? Anybody familiar with space history might recall that Sputnik, launched by the USSR during the Cold War, was considered the first man made object to enter orbit around the Earth, but it's not the first man made object to enter space. And then there's also an anecdotal evidence of a manhole cover that was shot off of the Pascal B underground nuclear detonation experiment. It has not been proven whether or not that manhole cover was actually shot into space, or if it might have burned up in the atmosphere before it reached outer space. Right now, that's the consensus of most of the scientific community, that it actually burned up in the atmosphere and there wasn't enough mass for it to actually survive the heat of exiting the atmosphere at such a great speed. The next contender is the bumper whack test. This was a Werner von Braun experiment to place a JPL whack Corporal missile on top of a German made V 2 rocket in order to intentionally reach outer space. Gaming Dicer 770 won this week's scavenger hunt with the German V 2 rocket, and that is the first man made object to leave the Earth's atmosphere on October 3rd, 1942, as a Nazi German height test that soared to 118 kilometers, which is just above the 100 kilometer altitude, or 60 miles, for the Kármán line. So, congratulations, Dicer. And he didn't give me a specific subject to answer for his question, so I'll go on to today's subject of orbits. So, what is the difference between just being in space and being in orbit? There's quite a bit of a difference. Being in space means you are temporarily there and you are going to fall back to Earth. This can either be considered a suborbital trajectory or a ballistic trajectory. Basically, you are going up and going right back down. And you might experience weightlessness like they do on the Vomit Comet. It follows a flight path to take you up and down that same trajectory to simulate microgravity at the top of their flight path. But it's an airplane in atmosphere. You are not going to space. Now, suborbital spaceflight is where you actually do go above the Kármán line, but you don't actually go into a circularized orbit over the Earth. So you go up and down, and that's about it. And that is where a lot of the commercial space industry is focusing their target for their audience. Just like with Spaceship 2 from Virgin Galactic, as well as the New Shepard space capsule thrusted by the New Shepard booster by the Blue Origin company. This is the same range that ballistic missiles, ICBMs, would be flying through outer space in order to come back to the Earth and fall on their target. So this is suborbital space, meaning that it doesn't actually go into that circularizing orbit. Now, an actual orbit is where the gravitational force of your larger object is pulling on the mass of the smaller object, but the smaller object is moving around the larger object. It has momentum. And when that momentum cancels out or is very close to the same force as the gravity pulling toward the center, that's when they cancel each other out, and they basically are in a locked tug of war to where the object is still orbiting the Earth but doesn't fall. Now, when we start talking about orbits, we start talking about apogee and perigee as opposed to altitude. Altitude being how high an aircraft is above the surface of the planet, whereas apogee is how far away that spacecraft's orbit takes it away from the planet's surface, and then perigee is how close the spacecraft travels to the planet's surface. In a circular orbit, the apogee and perigee could be the same exact distance. They don't actually get closer or further from the object that they're orbiting. The first orbit I'll be talking about is low Earth orbit, or LEO. And low Earth orbit is anything above the Kármán line, up to 2,000 kilometers or 1,200 miles above the Earth's surface. And this is the area that the International Space Station resides in, as well as the new Starlink satellite flocks and several other low Earth orbit communication satellite systems that are being developed by other countries and other companies. Now, a lot of times I'll say that if something is above the Kármán line, it is above Earth's atmosphere. This is actually a misnomer. Because there is something called atomic oxygen. That is, the atmosphere is so thin that you could have parts per million of atomic oxygen elements that high up. And that actually does create a drag force on spacecraft that are in orbit and does slow them down. So periodically, the International Space Station needs to actually be boosted up back into its original orbit. The Starlink satellites actually use this atomic oxygen to take advantage of that drag force to intentionally slow down their orbit and drop to burn up in the atmosphere as part of their end of life process. Now, medium Earth orbit is anything between that 2,000 kilometers and 35,786 kilometers. That's an area where the orbit of the spacecraft is not locked onto the Earth's surface like in a geostationary. It is still passing relatively fast. High Earth orbit is anything beyond that 35,786 kilometers. That includes the classification of orbit called geostationary orbit. That is where the majority of your communications and entertainment satellites are going to be at. And geostationary orbit is where the speed that the spacecraft is traveling over the Earth matches the Earth's own 24-hour day period. So, as the spacecraft is traveling over the Earth, it is focused on that one specific point in the sky. It doesn't travel very much in the sky in its orientation. Unlike the Starlink satellites, you probably have noticed a flock of several lights in a line streaking across the sky. That's been a bane of some astronomers recently. But with the geostationary orbit, it would just stay fixed in the sky in the same location, in the same constellation as if it were a star. And that concludes this episode of the Saxmo Space Show. Next week's scavenger hunt question is, what is the first man-made spacecraft to fly by the moon? The first person to answer the correct answer in the comments below, post your question that you would like me to address, and I'll answer that in the next episode. Until next week, may the force be with you, ad astra, so say we all, and live long and prosper.